and acceptance.
All right, good afternoon, everyone. I hope you're having a great day today at DevVox. At least I am already having a great day today, and the weather is lovely here in Krakow as well. My name is Willem-Jan Glerum. I'm a software engineer from the Netherlands. I work at a company called Lunatech, and we have offices, well, of course, the Netherlands, France, and Belgium. And we mainly do IT consultancy on the JVM, so Scala, Java, and a bit of Kotlin. And I'm here to talk about reactive Quarkus, so using Quarkus in a reactive way. You probably all heard about Quarkus already. There are some talks today, and I think tomorrow even more by Red Hat during the Dev Nation Day. So please check out that track as well tomorrow. I've been using Quarkus for the past 2.5 years. We actually got a nice project running in production now for the past half year, and it's all going smoothly and very well. So we're quite glad with that as well. Coming from my days when I was mostly doing Scala with Play Framework, everything used to be async and reactive by default. You could use both programming methodologies at the same time. In Quarkus at the beginning, it was mainly just blocking with a reactive core, of course, but the normal libraries like Hibernate were all blocking. So today we're going to explore how we can use those libraries in a non-blocking way. Before we dive into all this code, we're first going to go over why would you want to do reactive programming. We're going to see the differences between blocking and non-blocking code and how you write that and what the advantages are or disadvantages. Then we're going to have a look into Mutiny, the reactive programming language or library used by Quarkus. Then we'll dive into REST Easy Reactive, Hibernate Reactive, and the REST Client Reactive. And if time permits, we can also look at reactive messaging and show some stuff with Kafka as well. You probably all heard of the Reactive Manifesto before. It's all about being responsive. So always being able to deliver a response back to your customer or your client. To do that at the core, to enable that, you have to be message-driven. Instead of waiting for blocking calls to each other between services, if you send them through messages, then some other services can consume that message when it's ready. Or if you have a future use case, you can reuse those same messages for your new use case or your new service. To be able to always serve a response, we need to be elastic. So we need to be able to scale, have multiple instances running, not just one. And we have to be resilient. So what happens if something totally terribly goes wrong? We just don't want to time out. We will probably want to show a nice message to the user, say like, hey, this thing went wrong. Can you please give it another try? You can read more about the Reactive Manifesto yourself if you want, but that's a bit why you want to be reactive. At the core of most of your applications, what you do is you use I/O, and I/O is everywhere. So you go to some database, you wait for the database to give you some response, you go to some external service or some other microservice that you call, and you're all spending time waiting for that service to respond. Or of course, send a message to a broker or a queue. That may take some time as well. Most of the time it's fire or forget, that goes a lot quicker. But most of the times you spend, a lot of costly time waiting for some other thing to happen. And if you want to serve more requests at the same time, you don't have enough space or enough resources to handle all those requests. So we can do that a bit more efficiently. Well, if you stay just in the blocking world, everything is easy. You program sequentially, line by line. It's easy to reason about. Things execute sequentially, so not all over the place, but it's just step by step. Everyone can follow that and reason about it. That makes it also really easy to debug. With reactive code, that's a lot more difficult. It does come at some cost, of course, blocking code. Like I said, you're blocking your threads, so you can't handle more requests, and we have a limited amount of those threads. We can't keep on spawning more threads on your operating system, because then you just run out of memory or CPU. It just doesn't scale anymore, so we need more CPUs or bigger CPUs. On the other hand, when we're non-blocking, we just have a few threads, I/O threads, where we execute or handle those requests on. So the advantage there as well that we need less context switches. So your CPU doesn't have to switch from thread to thread. You can imagine if we block, it has to switch to another thread, do a bit of work there, has to park that in memory again and go back and forth. And especially with modern CPUs, with those cachings in there, it's actually taking more time. So yeah, we lose all the advantages. But if you go reactive, the idea is that we'll be able to handle more and more requests on the same CPU with lower latency and lower memory usage. This is best visualized in a picture. So we have a bunch of worker threads. In this case, we only have 2. Typically, you have like 20 or 200, or a couple of thousand maybe, but that really is the max mostly. Or you have multiple worker pools as well. So a request comes in on worker thread 1, it does some work, and then it calls the database, and does a blocking operation, parks the thread, waits a bit till it gets the result. But in the meantime, we have request 2 coming in. Well, luckily we still have a worker thread available, so we can handle the workload there. We do some other blocking operation, we park that as well, and then we end up waiting. This is a really simple example, just 2 threads and 2 requests. Well, what happens now if a third request comes in, you can't do anything anymore. The solution is add more threads to your thread pools or get a bigger CPU, get more machines. But like you see in the ping bits, we're just doing nothing and waiting. So we can probably do a bit better there. In the non-blocking world, we just have a bunch of I/O threads. In this case, we only have 1. And on that thread, we can handle multiple requests at the same time. So a request comes in and needs to do some I/O. Well, we schedule that I/O. And when the database comes back, we get a continuation of request 1. And we continue and respond back to the client, to the user. In the meantime, while we're waiting for that I/O, we can handle request 2. Well, that one does the same. It needs to schedule some I/O. And then we can handle request 3 simultaneously. So in this example, we can now handle 3 requests with just a single thread. And of course, this is a really simplified example. But in this way, if you scale that to a bigger infrastructure, you can handle a lot of more requests on the same hardware. In the Quarkus world, it's really easy to combine all this. Imagine you have some endpoints that just do blocking code. You want to transform some new endpoints that do some more reactive code. That can all happen at the same time. There is an event queue there, and the I/O threads listen to those events, and if they need to do some work, they do the work. But if they decide, well, there's actually a blocking operation, and I'll show you later as well that we can make that explicit in the code as well, then we switch that to a worker thread. So even if we're in the reactive world, doing everything on I/O threads, sometimes you still need to block. That's possible, then it will actually switch context and execute on your worker thread pool. And in the meantime, we can do all the other work with event handlers on the I/O threads. Like I said, in Quarkus, they use the library Mutiny. And that's one of the options you can use in Quarkus for reactive programming. But you could also use the completion stage with the completable future, or the publisher from reactive streams, which is used by RxJava and Akka Streams, for example. Or what I started doing recently, writing services in Kotlin, then you can use Kotlin coroutines with suspend functions. That will make it a lot more easier as well, but I won't be covering that today. So what is Mutiny? Mutiny is a reactive programming library and a toolkit to handle reactive code. The standard library in Java is quite limited in this regard. It's a bit hard to combine multiple completable futures or implement the observers or the subscribers for a completable future. So that's why they made Mutiny, where it makes it a lot easier. You can also use it standalone. You don't have to use that together with Quarkus. And it has 2 main concepts. It has a uni, which promises you a single event in the future. So looks a bit like a completable future. And this item can either be the item itself that you get eventually, or a failure, something went wrong in the meantime. On the other hand, we have a multi, and a multi gives me in the future a bunch of elements. It can be 0, nobody sends me anything, or it can be a finite set of elements, just a list of items that I get in the future, which I get then one by one instead of the entire list in one go. Or an infinite stream. Imagine I'm reading from a Kafka topic, someone is publishing events there, and the stream just keeps on going and going. The nice thing here as well with Mutiny, it fully supports back pressure as well. So if someone on Kafka is pushing too many messages in there, it'll actually not overflow your own application, but only handles them at your own pace. So imagine that on each event that I get or item that I get, I need to do a lot of work, and someone sends me thousands of messages, I can't deal with them, then it actually uses back pressure to say, hey, take it easy, I can only handle so much. These concepts are quite similar to what's being used in Spring Webflux, the reactive one of Spring, and they're called Mono and Flux, but they're roughly the same thing. And now you're wondering, how do I use this, what it's all about? So like I said, the multi can create a stream of elements. Well, in this case, it's a finite set of elements, A, B, and C. And then we can define in pipelines what we don't want to do with all this data when it comes in. So we say, if we get an item, I want to do something with them, so I want to transform them. Each element that I get, I'm going to make it the uppercase version of the letter. This is a different way of just saying .map. That will do the same, actually. And then nothing happens still. There's just a definition of my pipeline. Then I need to subscribe to that pipeline and say, what do we want to do with them? So if I then subscribe, I start consuming the elements from that stream. And, well, in this simple case, I just print them, or I print a failure. Then we have the second example. That's a uni. And that's only from a single element. So like I said, it guarantees you that you get something in the future, either the element or the failure. And that's what you see in the bottom. We subscribe to it, and then you get either the item or the failure in your logs. So this was a bit of the theory behind it, the concepts behind it, in a quick overview. You can read more about that online as well. From the Quarkus actually has some great documentation how the reactive engine works and how you can use it. And of course, we want to see some actual code, so we'll be doing some live coding today as well. We can go to the website and generate ourselves a brand new project. I'm going to take a little risk here today. I just saw that they released the 2.10.final release this morning, so we're going to give it a spin and see if it works. If it doesn't work, we'll have some fun on the way. We get to this nice website where we can generate our project. So we say we select the version. Well, it's actually the recommended version already since today. The Java version, well, we choose the latest LTS release. And we want to include some starter code. If we enable that option, we also get, in our generated project, get some sample code to get started with and to start playing around. Right now, the reactive ones are on top, so we'll be using REST Easy Reactive, the JAX-RS implementation, but the new implementation, which is now reactive. We want some JSON support as well. And as you can see, there's lots and lots of reactive extensions that we can enable on this project. We're also going to enable the REST client reactive, so we can call some external services. And they probably need some JSON support as well. And then the next one, which I'm looking for, is the Hibernate one. And I'm going to go here with the Hibernate reactive with Panache. So normally we have the normal Hibernate, but now in the preview mode, we also have Hibernate reactive, which is the reactive form of Hibernate. And then with Panache, it brings a lot of Quarkus goodies to make it really easy to use as a user. And last but not least, we want some messaging as well. And here we have the small array reactive messaging with the Kafka connector. As you see, we have some other connectors as well, like RabbitMQ, MQ2T, but I will choose the Kafka one today. Then we can simply download this application and extract it. That's what I already did just now. So here is my little project in VS Code. Just see it's using the latest 2.10 release and the Java 17. And then I get a nice simple project with some example code. It's really easy code, but at least gets you started. And it provides some other resources in there as well. So that's what we saw before. It's really easy to get started. If you were gonna give it a spin later today or next week when you're back home, just go to code.quarkus.io, generate yourself a project with some starter code, and you can start playing. We selected a bunch of extensions, and we'll go over them, how we can use them in the normal way, and how we can now use them in the reactive way as well. Some stuff I didn't touch upon. Quarkus focuses a lot of times on developer joy, so making it really easy and joyful as a developer to work with. That's also what I've experienced the last 2 years. It's really nice framework to work with on a daily basis and to develop applications with it. And mainly due to the hot reloading. I was used to the hot reloading from the Play framework back in the days, but it basically works the same. You change a bit of code, you reload the page, and it automatically recompiles. It also has the continuous testing, so in the background it's testing your code all the time. So if you tweak a bit of code, it runs all the tests, and it's smart enough that it will detect the code regions that you changed, that it only runs those tests, so it doesn't have to run the full test suite again. Next to that, we have also a dev UI, which I'll show later, and the concept of dev services. Lots of time in a project you spend setting up a database on your local dev machine or on a testing environment. Then you need to clean that data, keep some state. With dev services, it's really easy. I'll show you in a bit as well. It just spins up using test containers, spins up some Docker containers for you during dev mode, where you have, for example, data services like Postgres or Kafka, or Keycloak if you want. And if you then run some tests, it spins up another Postgres container for you to run those tests against. So that's why your test environment is locally isolated from your dev environment as well. So if we go and have a look at that, we can actually run this project. And I'm using the Quarkus CLI right now. So you just simply use Quarkus dev. And I'll make it a bit bigger as well. And you see it did a bunch of stuff in the background here for me as well. So if we have a look, it found my Docker environment and is actually spinning up some Postgres container for me as well in the background. And it configured that data source as well. So I don't have to be bothered with configuring this database now as well. No, the Quarkus extension takes care of that. It spins up that Docker container, gets all the information like the port number and all the mappings, and injects that config into my application as well. So that way, if I then try to access my application, it just works. I mentioned the dev UI as well. This is only available in dev mode, and a few extensions actually provide some goodies as well. So, for example, for my data sources, I can reset my database in dev mode. I can have a look at my dev services, so that's what you see actually. I have a Postgres container, and it injected that bunch of config just for me without me having to type that. It just automatically did that for me. Yeah, so it provides a bunch of information that you can use. If we then go back to our endpoint, this is the standard JAX-RS way to define endpoints with annotations. And it's pretty straightforward, right? So we have the path, hello, we have the method, get, and it produces some plain text element. That's also what we see if we go back here. We see this hello endpoint. Nothing special. It just works. And as you can see, I enabled the HTTP access logs here in the bottom. It executed this hello endpoint, and it did this on an executed thread. So it's actually doing this on a worker thread. And now we're wondering, how do we make this reactive? There's multiple ways we can do that. So we can see from this method that we're not blocking at all. So we can instruct the framework to say it's non-blocking. And if we then have a look, if we refresh this page, so in the background it now recompiles my code, and it happens instantaneously. That's what I really like about Quarkus. And if we now have a look in the logs what it did, we still call this hello endpoint, but it's now being called on a Vertex event loop thread. So it's actually running this now on an IO thread. So the only thing I had to do is drop this annotation and it works. That doesn't always work, of course. I'm now hinting to Quarkus, say like this is non-blocking. It's obviously because we just return a string. But if we be doing some blocking operation in there, Quarkus will also not allow you to do this. Say like, hey, you're blocking my IO thread now. Please don't do this. Mark it as blocking. So that's what we can also do, is mark it explicitly as blocking. But I was talking about using Mutiny, the reactive programming library. So what we can do instead is say, give me a uni of this string. So give me sometime in the future, give me a uni of this string. Well, we need to write some code around that. So we say, make a uni, create from, and then we have a bunch of things that we can create it from. So if you have some legacy code around, using completion stages, for example, that you want to combine, or some library that does only completable futures, you can just hook them in and transform them to a uni, for example. Well, in this case, we don't have a future, so we just have a simple item. We could also use a supplier, but in this case, it's a simple string. It's not costly to create, so we can just say, create it from this item. And it still works. And as you can see in the logs then, it's indeed running on an event loop thread as well. So we're not in the blocking world anymore. Well, this, of course, is a really small example. What can we do as well? So if we have this element, we can also say, what should happen if we hit a failure? Well, in this case, we just create a string, so nothing will really go wrong. But the Mutiny library actually provides a whole bunch of functions that you can use and explore to combine this and do other things as well. So we can log them. Then on every element that we get, it's going to print that to the logs. What can we do else? We can invoke some other functions. So if we get an element, do something else. So on each element, for example, call an external service in a non-blocking way and combine that result. We can replace them. There's a whole bunch of stuff. We can say on failure, so define what should happen if this fails. But instead of doing it that way, we still have the option to deal with exceptions. Normally in JAX-RS or REST-easy, you would have to define exception mappers in a separate file in a class and inject that as well. In this case, we can just define a server exception mapper right here in place, and we say, for example, illegal this one, yeah. And then we simply define in here what should happen if we get that exception. If you're used to doing this normally with REST-easy or JAX-RS implementations, it's a bit more work, but here I can just define a single exception mapper that is scoped to this resource or to this class. So for example, if I get that one, I'm going to say REST response.status internal server error, whoops, something went wrong. And if I now, instead of here, throw an exception, that won't be thrown by the framework and handled for you automatically. So that's really nice that you don't, if you want to mix and match some imperative coding, reactive coding, you can all do it at the same time. So choose your own flavors as well. Well, this, of course, were really basic examples, but we'll continue a bit for some more complex ones as well. But before that, I want to talk a bit more about REST Easy Reactive, what it does and how it works. So just like REST Easy, it's another JAX REST implementation. This one is built on top of Vertex and Netty, and there's really tight integration with Quarkus. You can't run it standalone, it's really tied together with Quarkus. The cool thing is what they told me, is that they have performance benefits for both blocking and non-blocking code. So this implementation, because it's tightly coupled with Quarkus, Vertex, Netty, they will be able to do some performance improvements. So what we actually did on the project is still use all the blocking code, but just dropped in this extension instead of the normal extension, and you get some performance benefits for free. And it's also the default nowadays when you generate a Quarkus application. Well, then the next thing, if we want to load some data from a database, normally with JDBC, that's always blocking. You go to a database, you ask it for some data, and with JDBC, it's always blocking. You can wrap that, of course, with some completable futures or some other ways, run them on a different thread pool with some other workers, so you isolate that so you don't impact your HTTP thread pool, for example. But what they came up with is Hibernate Reactive. So instead of the normal Hibernate ORM APIs, they now have the reactive version as well, together with Mutiny. And they also leverage the reactive SQL client, so not using the traditional JDBC drivers, but the ones built from Vertex, which are reactive by default. And they have some drivers, if I'm not mistaken, for Postgres, MySQL, DB2, Cockroach, MS SQL, and probably a couple more as well. And it's well integrated with Quarkus and Vertex. And like I mentioned at the beginning when generating this project, we do the with panache for developer joy. So with plain Hibernate, it can be quite cumbersome to write all your mappings and do everything. But the Quarkus extension with panache provides some nice goodies to make it really easy. So I'll show that in a bit as well. For that, I actually prepared another project. And well, my passion is also brewing beer, and I love beer. So I thought, let's make a small API that I can showcase for handling some beers. Let's start with the domain entity first. So we define a small entity, a beer. Well, in this case, I only care about the name of my beer. And I set some constraints on that. It has to be unique. I don't want to have duplicate beers in my database. The name can't be null, and the length is maximum of 40 characters. Then you see that it extends this magic panache entity. This is actually where the Quarkus goodies come in with panache. You can use in this matter the active record pattern. So from here, I can simply call beer.listAll. This is just some virtual method that the extension generates for you. And I can use some easy sorting as well in there. So I can really easily define my query. So get me all the beers from the database, sort them by name, or sort them by ID. Because when I'm extending from this panache entity, it also gets you automatically an ID. If you don't like the active record pattern, we can also support repositories. So instead of using the active record, we can define our classical repository, but we don't have to write all that code. We can just simply extend panache repository and then the extension again generates a lot of boilerplate that you normally would have to write. And then you can take this even a step further by taking the Hibernate Panache REST data extension, and then everything from the REST endpoints to this is almost auto-generated for you. So if you just want to write a simple CRUD application, yeah, it's almost effortless. Before we continue, let's stop this application before we start on the new one, otherwise we get some port conflicts. And instead of using the Quarkus CLI, I can also just use Maven to run my project. So that also just works. And if we now go to my application, we have this small demo. And what I did, if we now go to the dev UI, we can also select the Swagger UI, because I created the extension to include the OpenAPI with Swagger UI. And that gives me a nice client in the browser to interact with my APIs as well. So instead of having to do this manually with curl or manually in my browser, I have a nice web UI with Swagger. So let's get back to the code. I have some endpoints, so I have an endpoint to list all my beer. And this one is a bit weird, you might say. I'll make it a bit bigger as well. It's a uni of list of beer. And you would say, why not create a multi of beer, so I get multiple beers in the future? Well, in this case, we're still using a relational database, so not a streaming database. So the database will just come back with you that list of beers. And if I'm in the client, I want to get that list of beers in one go. If you would use more a streaming kind of database like Mongo, you could, for example, stream this end-to-end from the server to the client as well. And then it would make maybe a bit more sense to use a multi of beer. You get an infinite stream of beers. But in this case, we know the database is not too big. We just get a chunk of beers, and otherwise we'll use, for example, pagination to limit the sizes as well. Next, we can get the beers by ID. So again, using the active record pattern, it automatically has an ID, so we can find it by its identifier. A nice thing about REST Easy Reactive is that this is actually no longer needed, that path param. So normally you need to annotate it, say like, you already have it in the path, this ID. But here we can omit it as well. This would also just work. And it works because the variable name is the same as the variable name in the annotation, so it just works. That was a bit redundant in the normal REST Easy implementation. Now comes when we want to create a beer, that becomes a bit more difficult. Normally you would say we need this add post annotation and an add transactional annotation to actually store it in the database. But now we need some help from Panache to say, I want to do something with a beer and do that with a transaction as well. And this is where you see that the reactive programming then gets a bit more complicated. Normally you would just stick on an add transactional annotation and it would just work. And in this case, we need to define this pipeline, say like, I need to do this with a transaction. If I then save this element, I want to transform that, what I get. So when I persisted it, my database assigns it an ID, so I get the entity back with an ID. And then when it generate URI from that entity, so I can redirect my user back to the newly created beer. And that's what I do in the end then, as the last step, I get this URI and map it to a response. And again, here we define the server exception mapper just on the resource itself. Well, we can try that out. So if I try it out, I get a bunch of beers. So I just entered some random beers in here. So a Budweiser, a Corona, and a Heineken. And let's add a beer in here as well. We don't need to provide the ID because that's automatically generated. I just learned that Tyskie, for example, is a great Polish beer. Some of you might not agree, but I thought it was nice. And then we can insert that one into the database. So we say execute. and I actually pressed it twice. So on the second press, it gave me a server error. So let's enter something else. So just an example. And here you can see that indeed, if I submit that one, and here you see the call request that was used, and then the response. So indeed, when I insert my beer, I get this beer back. And if I then try it a second time, I indeed get an internal server error because this beer already existed. If you now have a look at the access logs here as well, you can see that has all been happening on event loop threads. So here is event loop thread 2. On my machine, you just have a handful of them. So it uses those event loop threads to dispatch actually onto. But also, just for my, normally there will be blocking with Hibernate, but with this approach, we can make it non-blocking and handle lots of requests at the same time if you want. What's next? Like I mentioned before, we can also transform something coming from a completion stage into a uni. So mix and match different programming language frameworks or the default JDK ones. Maybe you have some legacy code out there that you want to combine or didn't want to transform to write with Mutiny because that's too much work. You can also just keep on using your completable futures. And imagine that I have this beer service that gives me some beer from draft in the future. As you all know, it takes some time. When I ask the bartender for a beer from draft, it takes a bit of time before it's there. So I get a beer in the future, not directly. And we can have an implementation for that. And in this case, it's going to give me a Guinness. And a Guinness takes even way longer. You think it's finished, and then the bartender has to do another thing to finish off your Guinness beer. So this simple service gives you a Guinness in the future, and it uses a thread.sleep. Normally, you would say that's wrong. I don't want to use thread.sleep. But yeah, for this demo, it's a nice and easy way to delay a bit. If we then go back to this endpoint here, you see that my V2 service, where I can try out and get this beer, it keeps on loading and loading and loading. And eventually, I get back my beer. And indeed, I get back a Guinness. It doesn't have an ID because it has never been saved to the database. If we now have a look at what was happening in the backend, you see that we called this beer/v2 endpoint. That was still happening on the event loop thread. So I didn't block anything. I was just waiting there to eventually that other thing to finish for me. So in the meantime, I can handle other requests that are coming in as well. So with just a few examples, I hope I showed that it's quite easy now to use your traditional Hibernate endpoints or queries, but transform them, especially with the panache, to make it really easy to explore and use those APIs and be reactive at the same time. Of course, we don't always want to get data from a database. We want to get it from some external servers, from your microservice. That's what we see happen lately a lot. You call some other services to get some data. You need to do some transformations. And if I get that data, I need to call some other endpoint. But those services might be delayed, overload. You don't know what happened on the network. It might take ages before you get a response. And of course, if you have to do multiple of those calls, it gets worse and worse and worse. What we can do with the reactive version of that is call those APIs in a non-blocking fashion. So we can ask for the data from that other service, but in the meantime do something else. The nice thing as well, if something fails on the way, maybe some network latency or hiccup, you say, well, if this happens, just try it again. Normally, you would have to write that code yourself, maybe with a simple for loop, say like try it a couple of times and then break out of it. But with Mutiny, by default, you can have retry support or failure handling. So you can define in your pipelines, what should happen here. So if I call this endpoint, if it fails, maybe try again, but I don't want to try again endlessly, because otherwise I get in a big retry loop, and I basically have an amplification attack on my other services when I'm retrying all my requests hundreds of times. So we'll have a little demo for this one as well. This time not with beers, but with countries. Online you can find a nice public REST API which gives you some basic information about countries. And we can try and implement that. Normally you have the REST client from REST Easy. It's pretty straightforward. You say, I register this REST client, and I give it this config key. That makes it a bit easier to handle in the configuration. And then I say, at which path should I call my endpoint? So for example, I get the v2 of that public API. I get the countries by name. Normally, you would say, I get a set of countries, but with the reactive version, you get a uni of set of countries. So it promises you that in the future, you get back the set of countries that match the query that you gave it. And it doesn't give you a multi, it doesn't stream, so it doesn't give you the elements one by one, but it is more a promise that you get those bunch of countries in the futures. To make it work, we need a bit of configuration. And the only configuration is that we say, well, here's my REST endpoint. We could do that directly in the code as well, but it's a bit nicer to do that in the config. And what they recently added into the reactive version of the clients as well is request logging, or a request and response logging. So you can actually see in your logs what's happening. In the past, you would have to define your own filters, intercept the traffic, and deal with the raw bytes and write them to string and log them yourself. But here it's just a config key, so like, hey, log this data. They can be dangerous, of course, because you could have JSON documents of a few megabytes, and you don't want to fill up your terminal with megabytes of JSON, so you limit the body a bit, so it doesn't explode. If you then want to use this one, we can go back to that one. So we define this client. Next, we can define a resource and inject this client as well. It makes it really easy. You can just inject like this with the REST client annotation. You don't need to add inject. You can add it there as well, but it's redundant in this case. Or you can use constructor-based injection as well if you prefer that one. Now we get this client injected here in my resource, and I just follow the same pattern. So I expose another REST endpoint on my own application where I can query some countries. And you can see I get, again, this uni of set of countries. But here I say what you want to do when something fails. So if I say, if this call fails for whatever reason, network timeout, maybe an internal server error from that external service, I can say I want to retry. And I want to do that at most 10 times, because I don't want to overload that other service as well by running hundreds of retries. And when I'm doing that, I also want to log it. So I want to see if it's retrying. So you can see that there in action as well. And it's as simple as that. So you can make this as long as complex as you want, chain all those functions, combine them. Maybe when you get a country back, map it to some other object for your own domain representation, store it in a database, call some other endpoint where you can get some specific information about a country that you found. You can imagine it. If you now try to use this service, we can use this lovely Swagger UI as well. We can try and search for a country. So let's search for Poland. And indeed, we get some information back about Poland. If you now have a look back at the logs, what was happening here? Well, like you see, it's quite some data. So indeed, I'm logging the uni retry at most. So there's the first iteration. If it was retrying multiple times, you would see the number increasing. Then you see the debug information where I'm querying this REST API using the REST Easy reactive client, as you can see in the user agent here as well. I don't send it any body, because I just send it in the query parameters. Then I get back this response. Next, I parse this response and give it back to the client. And as you can see in the HTTP access logs, it's still running on the event loop thread. So we didn't block any worker threads here. Because when I was waiting for that service to respond, I could do a whole bunch of stuff in the meantime. And you can try searching different ways as well. For example, on the country key, it does some fuzzy matching. But then you see if I search for PL, then it matches a whole bunch of different countries where there's somewhere in that JSON document PL, I think. And if you scroll a bit further, you'll actually see Poland there again. So that was a small example how you can use this REST client. So you can imagine that we could mix and match those approaches as well. So store a beer in my database. If it's from a specific country, look up some country information about that beer. And the next step is, maybe I want to publish an event. I found a new beer. Then we can use the reactive messaging extension. As you saw before when we generated this project, we can use multiple event systems, like RabbitMQ, MQTT broker, but the most common one is Kafka, I would say. So I'll show you a bit how easily we can push those events to Kafka as well, and then again, also read them. In the code, they're actually called channels, because they're a bit like, they're agnostic. So they can also be in-memory channel that doesn't have to per se have to go to Kafka and get back to my application. I can publish them just on an event bus in memory. Or some other libraries out there that you can use. So that's why they're called channels in the code. Again, for this example, we included this REST or this reactive messaging client. And we can use that quite easily. So for this example, we won't use the reactive or the active record pattern, but we use the repository pattern for my beers to store them. And then I can inject a channel as well. And that's an emitter, so it's a channel for my beers out. So that's where I write my data to when I get a beer and I want to publish an event. If we then have a look, what we can do, well, for example, we can also stream the beers from the database if you would want to. So in this case, you could get a multi of a beer, but like I said, might not make much sense with the type of database that you use. We can get that by name again. But the more interesting part is here. I'll try to. When we get this beer, in the past, we only generated this URI and redirected. But in this case, when we insert a beer, after that beer has been saved, we know for sure it has been saved, it has been assigned an ID. Now when we get it back before we redirect the client, we're going to emit it. So the beer emitter that we injected above, so this channel here, we're going to say send that beer over there. Oh, that's really nice, right? So then I publish those events. I don't really have a use case for it, but at least all the beers that I saved in my system are in Kafka. Well, the next thing I can do is define an incoming channel, which I can just do by annotating this method. So normally, like here, you do something with a post or a get, but at this time you say it's incoming from a channel. So instead of coming from a REST response, you just get this from some channel. It can be in memory, from Kafka, doesn't really matter. And when I get this beer, like I said, we don't really have a use case yet, so we're just going to log that information. So when we save it, we publish the event, and when we get it back, we listen on those events and then write them to the logs. So when I try that, so let's see the version 3 of my endpoints. I can get a bunch of beers. I get my beers that were saved previously. and I can try and save a new beer. I'll go for a Dutch beer, a Hertog Jan. And I can execute that, and indeed it has been now saved. It doesn't like my beer. Let's see. Probably because of the space. Yes, without a space it does accept it. So we inserted this newly beer. We can query those beers as well. So if we go back to the query, indeed, my beer is there. It saved the previously one as well, but when I was trying to redirect me, it didn't like the redirect with a space in it. That makes sense. But now it should also be published to my Kafka topic. So what you can see, what happens here, we're still running on the event loop threads where I posted my beer. And I'm listening to those events, so as soon as a new beer gets published, we print out that beer. So with just 2 annotations, with my channel here to define the beers out channel and the incoming beers channel, I connected to Kafka. You never saw me set up Kafka because Quarkus did that before me in the background with dev services. And if I want to run some tests against it, it will spin up a new Kafka broker for me, and I don't have to worry about that configuration either. So that makes it really joyful for me as a developer, because if you've done that before, setting up Kafka with Zookeeper and everything, it's a bit of a hassle. And now it just happened in the back, set it up for me automatically, and I can just start using it and start coding with it. So that was it for today. We saw how easy it can be to get started with Quarkus, and especially reactive programming in Quarkus. It has some drawbacks, of course. It's a bit more complicated to do reactive programming. You have to chain everything together. It becomes a bit more hard to reason about. Also, if you have to debug code, well, good luck. It's all async, so it's a bit harder to do. It's a lot easier when it's just sequentially, and you can just hook a debugger into it, and it works. But it definitely can help you write services with higher throughput and in quite an easy way as well. And it's quite easy to get started. So thank you. You can find my contact details there. And if you want to chat about some more Quarkus, we can meet outside or meet tomorrow at the Dev Nation track from Red Hat as well. Thank you.